It often comes back to Avogadro in chemistry. So Avogadro, what a wonderful person, right? He went ahead and noticed or postulated that the volume of a gas is proportional to the number of particles in the gas. So volume is proportional to n. And again, we have to think if we're changing two things, we have to be holding the other two things constant. So we're holding pressure and temperature, and we're not changing these in these problems. So P and T is constant. So volume is proportional to moles. So if one goes up, the other goes up. So we can divide volume by the number of moles, and we can compare before to after. So volume over moles before is volume over moles after. And we can see how this applies to cars or trucks, actually. So if you have a big old truck, like this one here, you might go ahead and be impressed by its engine size, right? Maybe you've got an 8.2 liter engine. And if you ask yourself, what is that 8.2 liters telling you? It is telling you that when you have the cylinders that you're full of gasoline vapors, so gasoline, right, or petrol from England, it takes up 8.2 liters. And why do we care about that? Well, it turns out that the volume is proportional to the number of moles. So the number of moles of gas is much bigger in a bigger engine. And of course, when you ignite it and it burns and gives off all that heat, which you use to drive pistons and make your wheels go round, then the bigger the volume, the more energy you get out of it. And compare it to a nice English little mini car, like a Mini. And in a Mini, you might have a much smaller engine size, so maybe you've only got 1.8 liters. And we know that's proportional to the number of moles. So in a Mini, right, you've only got a small 1.8 liter vessel that holds the gasoline vapors in. And so when you burn it, right, you've got a much smaller amount of gas. So when you burn it, you get a much smaller amount of heat given out, so you get a much smaller amount of energy that you can transform into work. So that's Avogadro's principle. So if you're buying cars or trucks, right, and you're saying, oh, I really like that engine, it's 8.2 liters, and I can't imagine myself with a truck with a 1.8 liter engine, you're using Avogadro's principle, believe it or not. Of course, we have to hold pressure and temperature constant here, so we could take a turbocharger maybe, and in a turbocharger we might go ahead and we might increase the pressure of our gas, and so that means we would get more molecules inside. If it wasn't turbocharged, then the pressure would be lower, so we'd have less in there. So it really isn't fair to compare just the engine size. A lot of the newer engines have operated a much higher compression ratio, and so you can really squeeze in a lot more molecules of gas than in an older volume car engine, let's say. And because of that, we normally refer to what we call STP as a way to really compare these volumes. And so STP stands for standard, so that's the S in the word, so temperature. And you can probably guess what the P is standing for here. So it is pressure. So we have agreed to kind of look at these from a standard temperature and a standard a standard pressure point of view. And our standard temperature is 0 degrees C or 273 Kelvin. And our standard pressure is 1 atmosphere, or if you prefer 760 torr millimeters of mercury, or 101,325 pascals if you're a nerd. And what's really nice is if you're at STP, then it turns out 1 mole of gas always takes up the same volume, give or take, and it is 22.4 liters. And so when you get your gas bill, okay, if you use gas to heat your home, or you have a furnace or a water heater, then they normally meter your gas in volume. And if you've wondered why they meter it in terms of volume, well, volume is proportional to moles. But if you look at the fine print, they probably have a standard pressure and a standard temperature, in which case a given volume of gas always corresponds to the given number of moles or molecules of gas that they're piping into your house. But for chemistry land, a mole is basically 22.4 liters at our standard temperature of 0 degrees C and our standard pressure of 1 atmosphere.